Yo, what's up guys? I'm gonna show you guys a basic trig sub integration. So our integral is nice, dx x times x squared minus 7 square root. You can write the square root, you can write 1/2. I see something squared, but the other thing isn't squared. And then there's a minus. So let's try to figure out what this trigonomic function could be. It could be the sine, but what I see is tan squared theta equals secant. This would be our secant right here. Squared theta, minus 1. And there's our 1 right there. We just need to make this 1. So let's rewrite this as that doesn't change anything, right? Because if you square root, it just gets rid of it, and then you're back to the 7 we had. But this gives us something squared times something squared, the u squared minus a squared. I don't really like using that. It kind of confuses me, the formula. I like just knowing the trigonomic function. So we can let x equal secant. Well, we need the square root of 7, because we need the square root of 7 so that you can factor out the square root of 7, and then you get the minus 1 that we're looking for right there to be able to make this trig sub usable. So we put the square root 7, and then you see that if you put the square root 7 here, when you put it in for x, it'll get squared and it'll just be 7, and this is still 7 too, and you can pull a 7 out. But when you pull a 7 out, you pull out the square root of 7 because you're pulling it out of a square root. And then it's times secant theta. Let's take a derivative of that. Dx, it's a constant times that, so the constant stays. The derivative of secant is secant theta tan theta d theta. So what we have also done now is we have changed the variable. So when we do get to our final answer, we have to come back to x, which we have here, and we will solve for theta. You can do this step right now. Some people do that, some people don't. You can go theta, you can go theta equals secant inverse, or 1 over cosine inverse, but then you just need to flip the inside of it. I just keep it like this. There you go. Remember we said x is equal to that, so we have to replace all x's now. So let's write that now. And we're going to replace the dx on top with our d theta. Dx, well, not d theta, but what dx is equal to. And that's the square root of 7 times secant theta tan theta d theta all over, now we know what x is. Looks pretty good right now. Let's not cancel anything. A lot of people like to just start canceling things. Let's look at it a little bit. What's going to go inside of there? Well, it's going to be 7 secant, secant theta minus, remember what we said about this? Let's just change it back to 7 because the square root cancels the square, or the square cancels the square root. Now we'll start canceling some things. We can cancel the square root 7. Cancel the square. Secant. We have a tan theta up there. Okay. Some of you will already see the answer. Look how small the integrals. Okay. So we still have that tan theta on top. It has not gone yet. We're gonna pull out from this equation, we're gonna pull out that 7 so we can get this. So if we pull out a 7 out of a square root, we just